Okay, so we have this reaction. What is the first step that we need to follow?
We need to get the charges.
We need to get the charges. Okay, some charges are going to be given, and some others you need to apply the rules that I gave you for oxidation. Minor, you have to turn the camera on. So here I have a pure element. Pure element have charges of 0. Okay. Now monoatomic ions are equal to the charge. In this case, the zinc, the only element that is there, is equalized to the charge of positive 2. Okay? So this is the charge of zinc. The other charge that is known is the charge of oxygen. I have oxygen in the two sides, and I know that the charge of oxygen is negative 2. Now I just need to get nitrogen from the reactants. So how do I do to get nitrogen? I can do it with an equation, or I can do it mentally. First, I will do it with an equation. If I do it with the equation, I would say that I have that nitrate is composed of one nitrogen with three oxygen. And because it is an ion, I will equalize it to the charge of the compound, that is negative 1. Then I know the charge of oxygen, that is negative 2. So 1 times n is just n, and 3 times negative 2 equals negative 1. Nitrogen minus 6 equals negative 1, and this minus 6 can go to the other side by doing the opposite operation, that is negative 1 plus 6. 6 was subtracted, now it's adding, so you get that the total charge of nitrogen will be 5. Okay, so you can do it like that, or you can do it mentally. What I do to do it mentally is I say 2 times negative 2 times 3, which is negative 6. I add the charge, and then I just get the number without the charge. I mean without the sign. And this 5 is the same 5 that I got over there. So you can do it mentally, or you can do the procedure below. It doesn't matter, okay? Both ways are good ways to do it. One is faster, the other is not that fast, but the two numbers are correct. Okay, now, what is the charge of this nitrogen?
Or
I have negative 4 here, and I need to balance it, so this is going to be positive 4. Okay. So now that I have all my charges, I define what is being reduced and what is being oxidized. What element is being reduced?
Nitrogen.
Nitrogen is being reduced, okay, from nitrogen 5 to nitrogen 4. What element is being oxidized?
Zinc.
Zinc is being oxidized from zinc 0 to zinc 2, okay? So my oxidation occurs right there. Now, this is the step 0 from redox in basic solution. So what I do afterwards is I continue with the half reactions. Okay. So I begin with my redox. First, with my reduction equation, I'm going to write the half reaction. So I'm going to write the entire compounds that are involved in the reduction. So we say NO3 minus is producing NO2. Okay? So what I do after is I'm going to balance the elements. I have nitrogen and oxygen. I count the atoms in the two sides of the reaction. Nitrogen is 1 and 1, and oxygen is 3 in the reactants and 2 in the products. Now, to balance my amount of oxygen, what do I have to do?
Add water.
I'm going to add water. So here I need 1 oxygen. And to add 1 oxygen, I will add 1 water. Okay? So I say plus invisible 1 water. And now my oxygen is balanced. But I also included another element that was not part of the reaction. That element is hydrogen. So I need to balance my amount of hydrogens too. So I say hydrogen, I have 2 hydrogens in the products, but I have non-hydrogen in the reactants. That means that I need to add H plus ions. Okay? And my H plus ions will depend on the amount of hydrogens that I need. I need 2 hydrogens, so I will add 2 H plus ions. And now my hydrogen will be balanced. As you can see, all the atoms are equal. You have nitrogen, oxygen, and hydrogen, the 3 of them are balanced. So we balance the reduction reaction, the number of atoms. But we also need to balance the charges. So take a look to what we're going to do here. Okay, pay attention to this part. For this part, for the charges, it is necessary that we see the charges. Okay, as you can see in the reactants, I have a negative charge here and a positive charge over there. But in the products, you see that here there is no charge, and that you see that above water, again, there is no charge. Okay, you can place the 2H plus, you can place it here or you can place it there. It doesn't really matter. What matters is that is in the reactants part. Now, again, I repeat, you see that here I have charges, and in the products I have no charges. So we say the following, because here you see no charges, the charge is 0. Because here you see no charge, the charge is 0. Because here the charge is negative, the entire charge is 1. Because here you see the plus symbol, the entire charge is plus 1. Okay? And with this, we're going to start balancing the charges. Remember, the coefficients that you don't see is invisible 1. So we do like this. Invisible 1 times negative 1 from here, okay? plus 2 times positive 1 is producing invisible 1 times 0, this 0 from here, plus invisible 1 times 0, the other 0 from water. Okay? You know that when you multiply 2 times 0, you're going to have 0, so these terms are going to be cancelled. And in here you will have 1 times negative 1 is negative 1, and 2 times 1 is plus 2, and in the other side you will have 0. Negative 1 plus 2 makes positive 1, producing 0. Now, you see, the charges are not balanced. So how many electrons I have to add for it to be balanced?
One.
1 electron. Where? In the left or in the right?
Left.
In the left, okay? In the place where I have the number is the place where I will add the number of electrons, plus 1 electron. And this electron is the one that I will include in the reaction. 1 electron plus the rest of the reaction. And with this, I finish reduction. Now, I will focus on oxidation. In oxidation, I have just zinc in the reactants and zinc 2 plus in the products. As you can see, if we balance the number of electrons, it's going to be balanced because you have 1 zinc in each side of the equation, so it is already balanced. I don't need to add hydrogen, I don't need to add oxygen. Now, all I need to do now is I need to balance the charges. Remember, pure elements, the entire charge is 0. So we need to balance the charges. So we say invisible 1 in each side, okay? So we say 1 times, invisible 1 times 0 is producing invisible 1 times the charge of positive 2. This is going to be cancelled, so it's going to be 0, producing 2. So how many electrons I have to add?
2 electrons.
2 electrons in the right or in the left?
On the right.
2 electrons in the right. So I'm going to include it in the products, in the oxidation part. And with this, we finish the redox. Okay? Now all I have to do is put everything together. So I'm going to put them all together. Okay, like this. So I have my equations together. Okay, I'm just missing the charge over here, which is 2 plus. Okay, and now I see my number of electrons. My number of electrons must be the same. As you can see, they're not the same. So by what number I need to multiply the first reaction in order to have 2 electrons?
By 2.
I need to multiply times 2. So my reaction is going to be this one, okay? My reduction, after multiplying times 2, is going to give me 2 electrons plus 1 invisible times 2 is going to be 2 nitrates plus 2H plus. Here is H plus, okay? Times 2 is going to be 4H plus. That is producing 2 nitrogen dioxide and 2 waters. And in oxidation, I'm going to have the same amount. In oxidation, I'm going to have the same amount because I didn't multiply by any number. So it's going to give me the same. Okay? Now, what I have to do now? Now I have to add the two equations. Okay? I need to add all my reactants. Okay? And then I have to add all my products. Okay? And I will respect the position of each. So, I'm going to write everything in a single equation. So I will have 2 electrons plus 2NO3 minus plus 4H plus zinc, invisible 1 zinc, producing 2NO2 plus 2 water plus zinc 2 plus 2 electrons. I don't know if at this point you have any doubt on the procedure. Okay, okay. So in this point is where you start to compare whatever you have in the reactants with whatever you have in the product. If those numbers and substances are the same, are going to be cancelled. In this case, the only thing that is repeated in the two sides of the reaction is the amount of electrons. Okay? So, this number of electrons are going to be eliminated because they are the same number and they are located in opposite sides of the reaction. So whatever is left is the remaining reaction, okay? So the reaction is being altered to this. Now, in this step, after eliminating the electrons, what comes is, okay, here you eliminate the electrons, and here what you see is if you have like terms. Tell me, do we have like terms in here? Do we have like terms in the reactants and in the products that are exactly the same?
No.
No, we don't have any. The only one that looks like a like term is zinc, but they are different because this zinc is a pure element which has a charge 0, and the zinc in the product is zinc 2 plus, which is an ion that has a charge of 2 plus. So even though they look almost the same, they are not the same thing. So you cannot eliminate it. Okay? Now, listen to me. What I'm going to do now is an invented procedure. Me lo voy a inventar. Okay? But it has a purpose. Porque ustedes ya vieron que no hay like terms en los dos lados. Entonces yo me voy a saltar unos pasos. Pero no siempre es así. The step that follows is to get rid of whatever is repeated in the two sides. Now, this process in here is imaginary, okay? Imagínense que yo añado agua y H plus iron. Esto es imaginario, esto no está sucediendo, okay? But just imagine that this is the reaction that you have. Ahora les pregunto, ¿tenemos like terms? ¿Sí o no?
Yes.
Ahora sí, ¿verdad? Ahora tenemos H plus con H plus. Entonces, el procedimiento que pasaría si tuviéramos una situación de estas es que tenemos que restarlos. Okay? We need to subtract it. Ahora, ¿cuál vamos a restar y de dónde? Siempre vamos a restar el número más pequeño. ¿Ok? Entonces, por ejemplo, vamos a restar 4H plus, porque sería el más pequeño entre 4 y 8, el más pequeño es 4. Y entre agua, water, we have 2 waters here and 4 waters in the reactant. En ese caso restaríamos 2 aguas. Minus 2H2O, minus 2H2O. Este procedimiento nos sirve para eliminar el like term, ¿ok? Porque ese es el propósito. Cuando tenemos like terms, los tenemos que eliminar. ¿Cómo? Restando el más pequeño, el valor más pequeño. So, in this case, H plus, 4H plus se cancelarían y 2H2O con 2H2O también se cancelarían. ¿Ok? Y entonces a H plus me quedaría, no lo resté, pero me quedaría menos 4H plus. Y yo solo escribo el resultado. 2H2O y aquí 4H plus. Y copiaría el resto de la reacción. Pero como les dije, esta parte fue inventada. En realidad no está sucediendo, pero esto es lo que harían si eso pasara. ¿Ok? Eso es lo que harían. Pero como les dije, no está sucediendo, por lo tanto no lo van a hacer en este ejercicio. Now, after, ok, volvemos al paso real. En el último paso que nos quedamos era, verificamos que no tenemos like terms, ok. Y como no tenemos like terms, empieza lo que es el procedimiento basic. Vamos a convertir esta ecuación into a basic equation. In basic, an equation turns to be more basic when you add OH ion o el ion hydroxide. Entonces, ¿cuánto y dónde? We're going to add OH de acuerdo a los niveles de H plus que tenemos. Acuérdense que H plus es un indicador de acidez. ¿Ok? Y para neutralizar los ácidos nosotros añadimos OH. Entonces, nosotros queremos neutralizar la acidez that is located in here, H plus. Entonces, ¿cuánto OH vamos a añadir? The same amount of H plus. Tenemos 4H plus, entonces vamos a añadir esa misma cantidad, pero en ions OH. Entonces decimos 4OH, ¿ok? Pero como es una ecuación, whatever you do in the left must be done in the right. Entonces, como yo añadí esto, también lo voy a añadir en el producto. ¿Ok? Entonces me quedaría la ecuación transformada en esto. Ahora, there's another step that we do here, and it is the ion OH con el ion H plus. Cuando nosotros tenemos esto, okay, when we have all this, we're going to combine them. Lo vamos a combinar. We're going to join them. The purpose of joining them is to create water. Now, how much water? We're going to
4.
Same coefficient, that is 4. Entonces 4OH y 4H plus me producen en realidad 4H2O. ¿Ok? Entonces vamos a copiar la ecuación con el nuevo producto, that is water. So we have 4H2O plus 2NO3 minus plus zinc, that is producing everything that is in the right. Okay? And now the equation, as you can see, it has like terms. What is the like term that is repeated in the two sides?
Water.
Water. Water is repeated in the reactants and also in the products. Entonces, como les dije, cuando tenemos like terms, los eliminamos. ¿Cómo? Restando el más pequeño. So I'm going to subtract 2H2O in the two sides. Esta agua se va a eliminar y aquí me va a quedar 4 minus 2, nos va a quedar 2H2O. Y lo demás simplemente lo bajo. Todo lo que no alteré lo copio. And with this, we finish. We apparently finished. So now all we need to do is checking everything, checking the number of atoms and checking the charges. So I'm going to check the number of atoms, zinc, nitrogen, hydrogen, and oxygen. And I'm going to start counting atoms. I have 1 zinc in the two sides. I have 2 times 1, 2 times 1 nitrogen in the two sides. So I have 2 nitrogens in the two sides, in the two parts of the reaction. I continue with hydrogen. I have 2 times 2. I have 4 hydrogens in the reactant, and I have 4 times 1. I have 4 hydrogens in the product. I have oxygen. 2 times 1, 2, and 2 times 3, 6. I have 2 plus 6 oxygens, in total 8. In the products, I have 2 times 2, that makes 4, and 4 times 1, that makes 4. So in total, I have 4 plus 4, that also makes 8. So in here we see that the equation is balanced by the number of atoms. So far, so good, but we haven't finished, okay? Remember what I said before. This is an ion, this is an ion, and this is an ion. This is a pure element, which has a charge of 0. This is a compound, okay? This is a compound, and this is a compound. So in compounds, the total oxidation number is 0, okay? So now I will check the charges. So I will copy. I will do the same that I did in the first steps. I just put the invisible one for each zinc, and I will start comparing the charges. I have 2 waters that are multiplied times the charge 0. I have 2 nitrates that have a charge -1. And I have invisible 1 zinc that multiplies the charge of 0, all these producing the product. I have two nitrogen dioxide that has a charge of 0. I have invisible 1 multiplying the charge of zinc 2 plus, that is positive 2, and I have 4 as a coefficient, that is multiplying the charge of hydroxide, that is negative 1. So every number that is multiplied times 0 is going to be cancelled because it's going to give you 0. So negative 2 times negative 1, is going to be negative 2. And in the product, you will have 1 times 2, that is 2, and 4 times negative 1, that is negative 4. And this subtraction is going to give you negative 2. And negative 2 is the same in the two sides of the equation. And with this, that we compare the two numbers are the same, we say that it is also electronically balanced. The number of electrons is the same in the two sides of the reaction. And then if you want to make my life simpler, you can just write the final answer in a box, like I did right here.